Hi guys, I'm Krish Veera, and today, as you are informed, I'm gonna speak about mathematical paradoxes. So, guys, before everything else, let's just understand what is a paradox. So, the Google definition of paradox is a seemingly absurd or contradictory statement or proposition which, when investigated, may prove to be well-founded or true. In simple words, when it is put, it is basically a statement which will be true as well as false, and both the justifications are completely logical. For example, let's say this statement is false. Now, if this statement was false, that would mean that this statement was actually true. And if this statement was true, that would mean that the statement was false. And it goes on in circles and circles. And this is what this is what we call a paradox. So mathematical paradox plays with the same concepts, but this occurs when we play with numbers and ideas and theorems and those kinds of things. And today I will be covering two mathematical paradoxes. One is the Zeno's dichotomy paradox and the rich guest paradox. So without any further ado, let's just jump right into it. So the dichotomy paradox. So Zeno of Elea is credited with creating several famous paradoxes, and perhaps the best known paradox of all time is tortoise and Achilles. So I'm damn sure you all remember the story of the tortoise and hare. The slow and steady wins the race. But did you all know that that moral actually has a mathematical background to it? It was actually the story between the tortoise and Achilles. So tortoise had challenged Achilles to a race, but the only condition was that the tortoise had to be given a head start of 100 meters. Achilles said, definitely, why not? Still, I will beat you in the race. The tortoise reasoned out that the time you would take to cover up that 100 meters, in that time I would have gone ahead. And the time that you would take to cover up the other distance, I would have gone again ahead. So basically, the time you would take to cover up the distance that is there between you and me, in that particular time, I would have gone ahead, and therefore I will always remain ahead of you. And Achilles was baffled. He said, yeah, you would win the race. Now, we all know that that is not logical. So let's take the same paradox in another situation. Let's say there is a room and there are two walls, A and B. The distance between A and B is 2 meters. Now, to cover this 2 meters, I would first have to cover up 1 meter, right? I would first have to cover up half the distance. So half would be remaining. And to cover up this half, I would first have to cover up half the distance, which is half a meter. So half a meter would be remaining between me and B. So you get what I'm getting at here. To cover up a particular distance, I would first have to cover up half the distance, so that half would be remaining. Now, guys, the only thing that is problematic here is this statement is completely true. But by doing so, I would never reach zero, because half of a finite value, half of a definite value cannot be zero. Now, that means that I would never be able to cover up the entire distance from A to B. That also means that all motion in the world is not possible. Guys, we know that common sense and reality begs to differ. But what was the fault in what was the fault in this theorem? And how can this theorem be solved? Well, there is one simple algebraic way to solve this. So let's just say the sum of all these sub distances, like 1 meter, half a meter, 1/4 meter, is equal to s. So s is equal to 1 plus half plus 1/4. Now let's half this entire equation. So s divided by 2 is equal to half s, and 1 divided by 2 is half divided by 2 is 1/4, and so on. Now, when we subtract these two equations, what we get is half s is equal to 1, because this entire RHS will cut out this part and only 1 will be remaining. So half s is equal to 1 and s is equal to 2, which we know was the truth, which we know was the reality. So what exactly did I do here? What helped me out here? So the truth is, gentlemen, that a finite value can be divided into infinite sub-values. A finite time can be divided into infinite subtimes. A finite distance can be divided into infinite sub-distances. So infinite values can have a finite outcome. And with that, we come to the end of the first paradox. And now let's go to the second paradox. That is the rich guest paradox. This is not a paradox per se. It's a pretty extreme scenario, but nonetheless, it's very interesting. So let's say in this town, every single citizen is in debt with another citizen, right? Every single person is in debt. And the hotel, the only hotel in this town, is not really doing so well. And it is on the brink of closing. But one fine day, a rich guest arrives and he says that he wants to stay the week. But before doing so, he says that I want to stay one night to see how I feel. And if I don't feel comfortable, I won't stay the week. So the manager said that is possible. But for doing that, you would have to pay a certain amount of security deposit. Now, if you don't like the hotel, if you don't want to stay the week, you can take that security deposit back. Now, it so happened that the amount that was paid as the security deposit was the exact amount that the hotel had to pay its chef, to whom it hadn't been given its salary. Coincidentally, the chef's salary was the exact amount that the chef owed to the grocer from who he was buying groceries. And you may have guessed it, that amount the grocer owed to its florist. The florist owed that exact same amount to the doctor, and the doctor owed that exact same amount to its nurse. And since the nurse was new to the town, she was staying in the hotel, and she owed that exact same amount to the hotel. And you may have guessed it that the guest did not like the stay of the night at the hotel, and therefore he was given back the security deposit and he went away. But guys, did you see what happened here? No one really got the money. Everyone was handed the money, but no one really got the money. So the question that arises is, if everyone is in a debt, then is there a debt at all? And you think about it. And while you do so, also think about these two other paradoxes, which are pretty cool. So the two other paradoxes are the painter's paradox, which is the Gabriel's horn. So as you can see the shape, this is basically the graph of y is equal to 1 by x, which is curved around the x-axis. And it is limited from 1 is to infinity. It goes on till infinity. And this shape has an infinite surface area because obviously it goes on till infinity. However, it has a finite volume. So do research about this. And the other one is the grandfather's paradox. It's the time travel paradox about how you go back in time to kill your grandfather. And if your grandfather wasn't there, then your father wasn't there. And if your father wasn't there, then you weren't there. And if you weren't there, then how can you kill the grandfather in the first place? So do research about it. These are pretty amazing paradoxes, and it's pretty good to know about them. Go on YouTube, find videos, and go on this website called as brilliant.org. It's pretty good. So with that, I have come to an end of my presentation, and that's all, folks. And the main thing is to stay curious at all times. Thank you. That was Krish Veera.